Let's go the other way around. Let's take a regular equation like y equals x squared and turn it into a parametric equation. Now, these are the rules that you have to follow. Yes, you do need to memorize these. These are part of your memory test. However, good news is these are the very last rules you need to memorize in 1060. This is it. This is the last thing. So we have 4 different types of functions here we're looking at. We have y equals equations. We have x equals equations. We have line segments that go from one point to another point. And we have our conic sections. So these cover like ellipses, circles, hyperbolas, things like that. So let's look at example 4. In this first example, we have a y equals equation. So we're going to follow this set of rules. So our first equation is just going to be x equals t. Don't change that at all. Our second equation is going to be the equation given to us, but we're going to replace all the variables with t instead of whatever they are. So instead of x squared, I'm going to have t squared. And then I want to say from, just list the values they give you, from -3 to 2. And that's really it. That's all. So in the next problem, example 5, we have an x equals equation. So now I'm going to follow these rules. So my first equation is going to be x equals, and I list the equation, but I'm going to use t's instead of whatever variable they used. So instead of y to the 5th, I have t to the 5th. Instead of 2y, I have 2t and plus 1. And my second equation is just y equals t. And I have my parameters. It doesn't list any specifically, so this is just going to be from -infinity to infinity, since it doesn't give us any. Okay, looks like here we have a line segment from my starting point to my ending point. Now what I would like you to do is label these points. We're going to label this first one x naught, y naught, because it's the x and y values of our first point. And this second one, x1, y1, because it's the x and y values from our second point. Then all we have to do is plug these in to these equations here. So x equals our x naught point plus our x1 point minus our x naught point. And our y1 is y naught plus our y1 point minus our y naught point. And it's always from 0 to 1. So let's apply those rules. So we have x equals the x naught point plus the x1 minus the x naught t. And the y naught point plus the y1 minus the y naught point t. And this is always from 0 to 1 for line segments. So let's simplify this to get 2 minus t for the x equation, -3 plus 8t for the y equation from 0 to 1. And that's it. We're done. Last problem. This is going to turn into a conic section problem. We will need to start by completing the square on this. If that freaks you out, don't worry too much. There is no completing the square on any exam, on any final, on any test. There might be a couple on your homework, I'm not entirely sure. But we're just basically reminding you of completing the square from 1050, but it will not be tested in 1060. This is just like a slight reminder. So if you're looking at this and you're like, I really don't remember how to do this, don't stress too much. It won't be that big of a deal. So completing the square, first thing we do is cut this one in half, bring our square out, cut this one in half, bring our square out. Then we're going to foil it back together to do our check step. So I get x squared plus 2x plus 1 y squared minus 4y plus 4. And here's our built-in check step. Make sure that matches what we started with. And then these right here are the extras that I want to get rid of. So instead of plus 1, I'm going to minus 1 to get rid of it. Instead of plus 4, I'm going to minus 4 to get rid of it. So I have x plus 1 squared plus y minus 2 squared minus 9, looks like, equals 0. And then I'm going to bring this 9 over. And then finally what I'm going to do is divide everything by 9. The reason I'm doing that is if you come up here to our rules, notice that in our rule here, it always equals 1. So I'm dividing everything by 9 to force it to equal 1. So I have x plus 1 squared over 9 plus y minus 2 squared over 9 equals 1. Now it almost matches that equation I have up there. I'm going to do one more thing. Notice that my denominators are a number squared. So I know that 9 is 3 squared. So I'm going to change it to that. Because now essentially what I can do is, this is my h, this is my k, this is my a, this is my b. So h is going to equal -1, k equals +2, a equals 3, b equals 3. And now you can just take those numbers and plug them in to these equations here that you're working on memorize. So x equals h plus a cosine of t, y equals k plus b sine of t. It's always from 0 to 2 pi. Also note, this is specifically a counterclockwise orientation because that's positive angles on the unit circle. We always do counterclockwise as positive. So let's come up with my set. I got x equals h, which is -1, plus a cosine of t, and y equals k, which is 2, plus b sine of t, and it's always from 0 to 2 pi. So there we go. Let's do one more example of this, example 8 on the next page. We have x squared over 4 plus y squared over 9 equals 1. Notice this one you do not need to complete the square on. That's how most of your problems should be. So you just need to use the rules to come up with our x equals y equals equation. And then from what to what. And notice that I only want the left half of my ellipse. So what radians would give me the left half? So I want you to try this last one on your own. Pause the video, use those rules in that box to come up with your equations and what your parameters should be to give you the left half, and then come back to check and see how you did. Go ahead and check your work. So I got h and k are both 0 on top. A is going to be 2, b is going to be 3. Plug those into here. And if I want the left half of the ellipse, left half of the unit circle, goes from pi halves to 3 pi halves. So that's what I got there. So that is our last example for how to take an x and y equation and turn it into a parametric equation. We only have one more thing we're going to do with our lesson today, which is how we're going to change parametric equations. So like instead of these ones going counterclockwise, how do I change them to go clockwise instead? Kind of like changing the arrows. And that's what we'll talk about in the last video for today.